Hello again. Welcome to the fourth lesson on transformations on a graph. This one is about rotations. Okay, so you probably know about rotations from skiing or snowboarding. If you do a 360, you're pretty good. 540, 720, those are all tricks where you're spinning on the snowboard or skis. But we're going to talk about it in more of a math sense on a graph. Okay, so um, we need to learn a few keywords first to make sure that the activity that you do makes total sense, because there's some words that they use in there you might not be familiar with. So the word clockwise is just telling us that we need to rotate in the direction that a clock goes. So a clock always goes in this direction around, and that's, whoops, didn't mean to click there. So the direction a clock goes is clockwise. Okay, so if we're rotating like this, we're rotating clockwise. Counterclockwise is the opposite way, obviously. So we're rotating to the left, kind of. You could think of it that way. Okay, so the clock hand's moving backwards. So you need to know the difference between clockwise and counterclockwise. I won't do it on here because it might be wrong the direction I go because of the camera. You also need to know these main ones. 90 degrees is a quarter turn. 180 degrees is a half turn. A 3/4 turn is 270. And then if you did a 360, you'd just be back to the start. Okay? So we use these angles to tell us how many degrees we're going to move. If it's 90 or 180 or 270. Okay? And it's all from the starting position to the end position. So wherever we're starting, we're moving 90 degrees from there. Okay, so I'm going to show you a couple examples of that. So on BuzzMath, this is one of the first questions, and it says, move these blue corners, vertices of the triangle, into a position that is a 90-degree counterclockwise rotation about the origin. So the origin is our rotation point. The origin is here in the middle. And we're going to take this shape over here and we're going to rotate it this way, counterclockwise, 90 degrees. So we're going to take this one and we're going to rotate it 90 degrees. We're going to take this one and rotate it 90 degrees, and so on. Okay? So it looks like this. We take this point here, 5, 1, and if we rotate it 90 degrees, don't worry about the other points for now, but if you took this one point and you rotated it from here, okay, actually I'm going to draw a little shape to make it a bit more clear. Okay, so if I start here, this is the origin, this is our rotation point. Imagine if you were rotating something and you had a pencil on the end, it would be like the point where you stick the pencil. And it kind of looks like this. It's like attached to this little string, kind of. So if I were to rotate this 90 degrees, it's going to look something like this. It's going to go up 5 and over 1 square. So my new point is here. And you can see that it went from being over here in the corner to up 90 degrees. All right, so that's my first point, and we'll call it A prime because it's the result of me rotating it. Okay, so I'm going to just erase that bit here. And on BuzzMath, you can draw on the screen also to help you. Okay, and then the next point, B, okay, it's the same, but it's a little further away. So it's still gone over 5, but now it's gone up 3 squares. Okay, so when we rotate that counterclockwise, it's going to be the same, but it's going to be up 5 from here, and then over 1, 2, and 3. So B prime is going to be over here. Okay, and we can connect those together because we're going to eventually draw the triangle. And then this one is 3 and 4. So when we rotate it, let me just erase this bit. Okay, so you imagine if you rotated this L shape, it would bring this point on the end, C, would bring it over, up 3 and over 4, over to here. Okay, and if we connect them all together, kind of looks a bit more clear that would be the rotation. 90 degrees. Okay, remember 90 degrees is like that. Counterclockwise is going this way. Okay, and you can move the points around on BuzzMath to get this, and this is what the answer would have looked like if you were to have done it. Okay, perfect. Oh, look, it's even right on top of my drawing. I'll probably get rid of all of these things so that it's a little more clear for you. Okay, but they've labeled them A, B, and C primed because they're the result of the movement, and that's one technique, is to just kind of map it out and see what it would look like if you were to rotate it 90 degrees in this example, counterclockwise. Okay, good luck with it. Please, if you do have any questions, just message me or send me an email and I will reach out and try and help you as best I can. Okay, good luck.